All right, this is number 3 of series. 2 resistors are connected in series to a 10-volt battery. Resistor 1 is 3 ohms and resistor 2 is 2 ohms. Okay. All right, so we're going to start with doing the schematic. Okay, so here, put my voltage circles. Okay, might as well stick another one there. Put an ammeter up here, another one. Okay, there's my resistor. Circle in there. Resistor, circle there. And then I'm going to have another ammeter down here. Boom. Okay, right, so notice I got rid of quite a few of the circles that are in the picture, okay, which is fine. So just, as you get better at it, it's fine. If you want to draw every single circle that's in the picture, that's okay too. If that makes you happy, go ahead. Okay, so I said it has a 10-volt battery, so know that that's going to be the total. All right, resistor 1 is going to be 3 ohms. Resistor 2 is going to be 2 ohms. Okay, so let's go ahead and label these resistor 1, resistor 2. All right, and that's all I've got. All right, so let's go ahead and start filling in the voltage circles. So 0 volts at the bottom of the battery. Carry that around until you hit a resistor. Okay, always do this first. I'm not even joking. Okay, do it first. All right, 10 volts here. Carry that around again until I see a resistor. Okay, all right. So in this example, right, we can see that these 2 resistors are going to have to share a 10-volt drop. Okay, but they're not sharing it equally now because resistor 1 is 3 ohms, resistor 2 is 2 ohms, okay? So they're going to share unequally. So the voltage drops are not going to be 5 and 5, right? Because these resistors are now unequal, okay? So remember I gave the example about the mom like doling out money to the kids, okay? So in this case, which kind of doesn't make sense, the more difficult kid is going to get more money. All right, the easier kid is going to get less money. Okay, but that's not an invitation to be difficult to your parents, okay, because it's just an example. All right, okay, so let's take a look at what we've got. So I'm going to do V equals I times R. Okay, and I don't have 2 of anything in order to calculate. Okay, so I have to go to what I know about series circuits. All right, and one thing I know about series circuits is the resistors add to the total, right? Because remember I had this. Okay, so now 2 plus 3, I know the total resistance is going to be 5 ohms. Okay, that's for the whole circuit. So what that means is that would be equivalent to drawing a circuit like this with a 5 ohm resistor. Okay, so when they're in series, it's just like they act like they're just one resistor that's a 5 ohm resistor. Okay, so then I know if this is 10 volts, oops, okay, come on thing. Okay, right? And then if I use my Ohm's law, V equals I over R, okay, or I equals V over R like we got in the lab, 10 volts into 5 ohms is 2 amps, okay? So that means that I'm going to have 2 amps of current flowing through this circuit, all right? Since it's a series circuit, again, I have to know that that means the current is the same everywhere, so I'm going to fill in all that. And then I can go ahead and fill in my ammeters because they're all going to be the same in this case. Okay. All right. And then my last thing to do is just fill out these voltages. So if I know that V equals I times R, if I multiply these 2 columns, I'm going to get the voltage. All right. So that's going to end up being 6 volts and 4 volts. Okay. Which adds to 10, right? Because it has to add to the total. Okay. Remember V1 plus V2 has to equal V total. Okay. All right, so let's go ahead and finish out the picture. So I know if this has a 6-volt drop and this one has a 4-volt drop, okay, this is what a lot of people are going to mess up. Okay, so watch carefully. In this circle here, okay, I need to track the voltage at that point, which means if it was 10 volts, now I've lost 6 volts. That means this is going to have a 4 in it. Okay, because then I'm going to lose another 4 volts to get to 0. All right, so this is key. This is something that a lot of people mess up. Okay, so watch that closely. Okay, all right, now all I have to do is do my graph. All right, everything else is done. A, B, around this guy, C, D, around this guy, E, F, and that's it for this case. A, B, C, D, E, F. All right, so I'm going to go 2, 4, 6, 8, 10. 10. Kind of crappy there. Okay, so at A, we've got 0 volts. At B, we have 10, right? That's my plus 10 volts right here on the battery. It went from 0 to 10. Okay, continues at 10 all the way to point C is still at 10. So that's going to be a flat spot in a wire. Okay, and then my drop here is 6 volts to end me at 4. All right, so it's actually going to drop all the way down to 4 here with a -6. Okay, D to E is still going to be at 4. Okay, then I'm going to have my next drop of 4 volts down to 0, and then I'm going to continue it back to the battery. Okay, so you can see here that I'm going up by 10 volts, crossing a wire, dropping across the first resistor, dropping a wire, or going across a wire, dropping across the second resistor, heading back to the battery. Okay, that's what it should look like. All right, good.